Hello, hello. Today in math, we're going to talk about functions, specifically horizontal stretch versus shrink. First, let's read the question, because reading is half the battle. Determine if f of x is equal to the square root of 2x has a horizontal stretch or shrink. Let's bring out the facts when functions shrink and stretch horizontally. We know that y is equal to f of c of x. So the function shrinks horizontally when c is greater than 1. And stretches horizontally when 0 is less than c is less than 1. In our case, f of x is equal to the square root of 2x. So, the square root of cx is equal to the square root of 2x. So, c is equal to 2, which means the square root of 2x shrinks horizontally by a factor of 1/2. Sweet! We are finished. But that means we have to memorize some facts. Let's use some logic to solve this. First, let's create a table of our parent function, f of x is equal to the square root of x, where we have the inputs, which are x, and the outputs, which are y. So let's use some numbers, 0, 1, 4, 16, and 36. And the results of that are 0, 1, 2, 4, and 6. Let's flip the input and the outputs. We will see why in a second. Now, let's make a table of our function f of x is equal to the square root of 2x. Since we're comparing the square root of 2x and the parent function, the square root of x, we want the same input values of the function. But that means we have to make the x value smaller because of the 2. So now our inputs are 0, 1/2, 2, 8, and 18. But our output values are the same, 0, 1, 2, 4, and 6. Now, let's put this on a graph, so we can see it visually. We had to rotate the question so it wouldn't overlap the graph. First, let's graph the parent function, f of x is equal to the square root of x. Let's plot the points. Now, let's connect the dots. Oops, we have one off the grid. We will see why that's important in a second. Now, let's graph f of x is equal to the square root of 2x. We have our points. Let's plot them on the graph. Now, let's connect the dots. Let's get rid of that table, so we can focus on the graph. Let's take a look at the output values. First, let's start with the output value of 1. The original input value is 1, and the new input value is 1/2. So we multiplied 1 by 1/2 to get 1/2. Next, let's take a look at the output value of 2. The original input value is 4, and the new input value is 2. So we multiply 4 by 1/2 to get 2. Next, let's take a look at the output value of 2.82. The original input value is 8, and the new input value is 4. So we multiply 8 by 1/2 to get 4. Last, let's take a look at the output value of 4. That is the reason why we had one of the points off the grid, so we can compare 2 points. The original input value is 16, and the new value is 8. So we multiply 16 by 1/2 to get 8. So our c value is 2. And all the input values of our function f of x is equal to the square root of 2x is half of the input values of the original function, or the parent function, f of x is equal to the square root of x. So it takes half the time to get the same output value because our c value is 2. And since the c value is greater than 1, we have a horizontal stretch. The last thing we can do is move the original function or the parent function horizontally to show you that the two graphs will overlap no matter the c values. And there we have it. The two graphs overlap. And remember, there's always tomorrow. Bye-bye.